Let's look at a couple of examples for the two-port network transfer functions. The first one here we have the amplifier with the 2 ohm resistance, 1 ohm resistance in parallel with the capacitor impedance 1000 over S. And in that case, C would be 1 millifarad, right? Remember 1 over CS, that's equal 1000 over. So that 1 over C is 1000, so C is 0.001. And we're trying to find the voltage transfer function V2 and over V1. And here we recognize this is the inverting amplifier. And in this case, and the TVS is equal V2 over V1S is equal negative Z2 over Z1S. Remember what they add, the Z1 and Z2, and Z2 is, in this case, Z1 is equal 2 ohm resistance, and the Z2 is the parallel of this 1 ohm and 1000 over S. So we can use 1 over the sum of admittances, 1 over 1 plus 1 over 1000 over S. Right, so in this case we got 1 over 1 plus S over 1000, and we multiply by 1000, so in this case we got 1000 over S plus 1000. Right, so in this case we get the transfer function here, TVS is equal negative Z2 S over Z1S. That's equal Z2S is negative, Z2 is 1000 over S plus 1000, and Z1S is just equal to 2, so we get negative 500 over, let me write it down here so it don't interfere with the other things. So I get a negative 500 over S plus 1000. Right. So that's the network function for this example. Let's look at another example. Here we have the passive. In this case, we don't have an amplifier or the passive components. And in this case, we're trying to find the voltage V2 over V1 and trying to find the transfer impedance I sub 2 over V sub 1. Let's start with the voltage transfer function. So TVS is equal V2 S over V1S. In this case, if you can recognize the circuit, right? So this one here, if we can find this ZEQ first, and in this case, this would be the voltage across this is straightforward, the voltage division, right? So in this case, that's going to be equal to ZEQ over 5S plus ZEQ. Let's use ZEQS. And in this case, ZEQS is equal to the parallel of the 2. You can use a product over sum, or you can use 1 over the admittance, right? We did a few times, so I just choose one of these. Let's use the product over sum 2 times 2S over 2 plus 2S. And that's equal to S plus 1, 2S over S plus 1. Right, and so therefore the TVS is equal 2S over S plus 1 divided by 5S plus S over S plus 2S S plus 1. Right, so since I have S all over, so I can cancel this S first, then I multiply by S plus 1, multiply by S plus 1. So in this case, I get 2 on the numerator, right? S plus 1 being canceled, S already gone, So in this case, I got on the denominator, I got 5s plus 1 plus 2, right? Because the s is already gone. So I got 2 over 5s 5s plus 7, right? So that's the voltage transfer function, right? And let's see, find I2 over, so the transfer impedance, transfer admittance. So I2s over V1s, and this one is not straightforward, right? So I can't really get this thing right away. So let's see, I just use V1 as, treat V1 as a known variable, right? As trying to solve for I2. How I can solve it very quickly? So you could use the voltage division, then divided by the impedance. Find that voltage first, find V2 first, and then divided by the impedance, right? Or you can use the source transformation, right? So let's see, if I do the source transformation, what I'm doing here is I'm trying to find them. So I'm kind of reformulate the problem. Find I2 given V sub 1s. Okay. So in this case, if let me zoom out a little bit so I don't lose the circuit. And so in this case, I'm doing the source transformation here, and in this case, and this is gonna be the source transformation, and I have all this the impedances, nothing really changed. And so in this case, I have a 2s. So this here I got an I2s I'm trying to find. So this is 5s, and what is this current source should be? That should be the voltage divided by that impedance, right? So that should be V1s over 5s. So in this case, I can do the current division, right? So I2s should be equal to I2s should be equal to let's see, the total current divided by, so in this case we have 3 impedances in parallel, right? So we're gonna use the general form, which is the admittance of that element with 1 over 2, and over the sum of the admittances 1 over 5s plus 1 over 2 plus 1 over 2s times the total current, which is V sub 1s over 5s, right? So let's see the 5s. So in this case, the 5s, if I multiply by 5s, or maybe we should do, I don't know. Let's see, do 10 multiply by 10s first. So I multiply by 10s. So in this case, I got a 5s on the numerator. I got 10s, so I got a 2 plus 5s, right? Plus 5 times the V1 divided by 5s. So in this case, this 5s is going to be cancelled. I got a 5s plus 7. So I got a V1 s over 5s plus 7. So therefore, the transfer impedance T sub y s is equal I sub 2s over V sub 1s. That's just equal to, based on this, just equal 1 over 5s plus 7, right? So this is the this is the transfer admittance. And in this case, actually, we have a little shortcut. We can utilize the things we already calculated, but in that case, we are taking the risk of maybe carrying over the error you had in the previous one, right? But if you're confident that you did it absolutely correct, and this shortcut may save a little bit of time. Okay, so let's see. The shortcut as I did in the Google Colab notes, and I have this T sub y is I2 over V1. So what I did is I multiply this by V2, and I multiply by V2 And in this case, I'm rewriting this as I sub 2s over v sub 2s times v sub 2s over v sub 1s. And this one here, we already figured this out, right? So this is t sub vs. We already figured out in the previous step. So that's one here is 2 over 5s over 5s plus 7. And this I sub 2 over v sub 2, this is just the admittance of this element, right? The admittance here is the 2 ohm resistance. The admittance is just 1 over 2. So in this case, I get fairly quickly this 1 over 2 times 2 over 5s plus 7. So I get 1 over 5s plus 7. So I also get the same result, right? And so this is a little quicker, but you are taking the risk of carrying over the errors from the previous one. Okay, so you see this still boils down to how you analyze the circuit, right? So the things, if you're confused about the voltage division and current division stuff we learned before, you're gonna struggle in this chapter as well. So make sure you clear all the things that's confusing, right? So that's about it for this lecture. And remember, no matter what you do, just keep going and never stop. I'm gonna see you next time.